All right, let's dive in. Today, we're going on a little journey to really understand one of the most powerful forces shaping our world: data. We're going to see how simple, raw facts get transformed into this incredibly valuable asset that drives, well, everything: business, tech, even the choices we make every day. So let's get started. So take a look at this. What could a list of when people log in, a single receipt from a store, and how much rain fell today possibly have in common? I mean, on the surface, they seem totally random, completely unrelated. But they all share a fundamental identity, and figuring that out is the first big step. And the answer is, they are all forms of data. This visual here just nails the difference. On the left, you've got the raw, unprocessed facts, the individual login times, that one lonely receipt. But on the right, that's what happens when you process all that data. It becomes information. We're talking useful stuff like sales trends or average purchase sizes. So here's the main idea. Information is just data that's been given some meaning, some context. Let's make that official. Data, in its purest form, is just the raw facts we collect. Think of them like individual Lego bricks: a single temperature reading, one login time. By themselves, they don't really tell you much of a story, do they? But when you start organizing and analyzing those bricks, say averaging the temperatures for a month or charting login times to find the busiest hours, you create information. Suddenly that data has meaning. It is context. And now it's incredibly useful for actually making decisions.
Now, here's the thing. In our modern world, the problem isn't just collecting data. It's that we are practically drowning in it. This brings us to a huge concept called big data, which is usually defined by three big challenges, what we call the 3 Vs.
First up is volume. And wow, the amount of data being created is just staggering. It's estimated we now generate over 100 zettabytes of data globally, every single year. To put that into perspective, 1 zettabyte is 1 trillion gigabytes. The sheer scale is it's almost impossible to even comprehend. Next, we've got velocity. This is all about the insane speed at which data is created and needs to be processed. Just think about the constant, nonstop stream of data from the stock market, or from social media feeds, or from all those smart devices in our homes. It literally never stops. And finally, there's variety. You know, modern data isn't just neat little rows and columns in a spreadsheet anymore. Not even close. It's everything. It's text, it's images, it's videos. It's even unstructured stuff like social media posts and scanned notes. This messy, complex mix presents a huge organizational challenge. So how in the world do we manage this chaos of volume, velocity, and variety? Well, we have to create order. We need a system, sort of like digital libraries designed specifically to store and organize it all. And that brings us to the world of databases. At its core, a database is just an organized system for storing data. Its whole job is to structure information, usually into tables, and, this is key, allow lots of people to access and work with it at the same time. It's pretty much the foundation of every modern app you use. So the most common type is what's called a relational database, which organizes data into tables, just like this one. What we're looking at is a simple customers table. Each row is a unique record, one customer, and each column is a specific detail about them, like their first and last name. See that customer ID column? Notice how each customer has their own unique number? That's called the primary key. You can think of it like a social security number for that piece of data. It's a one-of-a-kind identifier, so we can always find that exact record without any mix-ups. Okay, now let's look at a second table for tracking orders. It has its own primary key, order ID, but look closely at that customer ID column. You'll see those same numbers, 102 and 101, from our first table. So what's that all about? That customer ID in the orders table, that's a foreign key. It's a special field that creates a link by pointing back to the primary key in another table. And that link, that is the relation in a relational database. It's how we connect John Smith to his specific order, creating this powerful, organized web of information. Pretty clever, right? Okay, so our data is all organized. Now for the really fun part, turning all that organized data into actual decisions. This is the world of analytics, and we can think of it as happening on 3 different levels. I like to think of it as climbing a ladder of insight. At the very bottom, we have descriptive analytics. This is all about looking at the past and asking, what happened? Think reports, dashboards, things that summarize historical data to find patterns. Then you climb one step up to predictive analytics. This is where we use that past data to ask what will happen. This is where forecasting comes in, predicting future sales, for example. And then, at the very top of the ladder, we have proscriptive analytics. This is the most advanced stuff. It answers, so what? What should we do about it? It doesn't just predict what's going to happen, it actually recommends specific actions to take to get the outcome you want. So, once our data is collected, organized, and analyzed, it becomes this absolutely priceless asset. And just like any other asset, it needs to be protected. This brings us to our final and absolutely crucial topic: backups and disaster recovery. Let's be really clear about this. Backups are the foundation of any disaster recovery plan. Without a safe, secure copy of your data, one hardware failure, one cyber attack, or one flood could just wipe out everything. Backups are the essential safety net for your entire digital world. Now, where you store that backup is a huge decision. Local backups, think hard drives or tapes right there in your office, give you super fast access and total control. On the other hand, cloud backups store your data somewhere else entirely, in remote data centers. This gives you amazing protection from local disasters like a fire, but you will need an internet connection to get your data back. But listen, there's one critical step that people miss all the time. Just running a backup is not enough. You absolutely must perform verification. That's the process of actually testing your backups to make sure they're complete, they're not corrupted, and most importantly, that you can actually restore from them. Because let's face it, a backup you can't restore from is completely useless. And that brings us to the single most important question you should be asking about your own data strategy. It's simple. Your data is backed up, but in that moment of crisis, is it truly restorable? Answering that question honestly is the difference between a close call and a total catastrophe.